Because I gave you this time, so no problem.
I yeah, I spent the last few hours going over all the practice problems from this chapter, and
Mm-hmm.
I I was running into a little roadblock with this problem, but I just figured out what I was doing wrong, and
Mm-hmm.
I figured out that I need to remember when it comes to these electrolyte solutions that I'm dealing with an aqueous solution because
Mm-hmm.
when I first I'll try and do this quick. When I
Okay.
when I was approaching this problem, I was like, okay, I'm gonna have to use just, I was like, I'm gonna have to use delta TF is equal to I KF
Yes.
molal, and
Mulai.
I was like,
Yeah.
okay, what do I have to work with? I have delta TF, which is
Mm.
which was this right here,
Yes, you're right.
and then I have the molality right here,
Yeah,
and
you're right.
I was like, I need to figure out I, but I was
Mm.
like, what's KF? And I was like, well, first I'll have to solve for KF. So I was like, so I solved for KF
Mm.
equals yeah, delta TF over just the molality without the I in the equation. So I got the value for KF and tried to fit it back into the equation, and it didn't work. And I was
No,
like,
it's not going to
what the
work.
heck?
Yeah.
So I looked at this answer and I was like, okay, if that's what they're given for I
Mm-hmm.
replaced the 121 and I solved for KF. So
Mm-hmm.
the KF, equals and it came out to be 1.859,
86.
and I was
Yeah,
like,
1.86 roughly.
and I was like,
Yeah.
man, I gotta
Actually,
remember,
it's not only your fault.
you know.
It's also their fault. Why? Let me explain this thing. Basically, they of course normally we assume it is aqueous solution if they don't give that one,
Hmm.
but they have to write the word aqueous solution.
Yeah, yeah, you're right about that. You're
So
right.
that's their mistake also.
Yeah,
Okay.
yeah. I was doing a bunch of problems getting the molar. One thing I really couple. I love I love all those tricks that you give me, but
Mm-hmm.
I really enjoy the um, calculating the molar mass with the alternate molality uh, equation or formula in the delta TF or TB for the boiling point, and the
Yeah.
yeah, it really helped me speed things up quick,
Yeah, yeah. That's like the fast. You can speed up
and
the
and it was
whole process.
it was really good, and also the one with the molarity. So the whole W2 times 1,000 over. Yeah, I was those came into play with like I did all the book examples and then the practice exercises with them. So just for this chapter, but yeah, yeah, I've been doing it all day pretty much.
Okay, that's you are going to do
Um,
that. So let's try what you want to try the.
yeah,
Let's try
if
osmotic pressure problem. Okay.
yeah, if you have
Yeah, we
any
have and I
problems
can
like
make
that,
here directly, no problem.
I'll try and do some of those.
Yeah. First of all, let's go to the osmotic pressure formula.
One thing before we
Hmm.
start, I made this. Um, I made a. I want to make sure that I'm understanding this correct, so I'm gonna load this in. It's a chart, and it goes with what everything that we discussed about the colligative properties and the relationship.
Hmm.
So
Okay, this formula you don't have to use it. Like for example, I have written here because this one is this thing because it is only work. Let me have a go. Oh, you made this one.
yeah, is this? I just wanted to know if this was like
Mhm.
accurate. So comparing colligative properties of two solutions.
Can you bring it on
Yep.
the center so I can?
Oh yeah, absolutely. Is that
Okay, now I can see. Molar concentration. Okay, vapor pressure, freezing example 1.00 molar, zero point 0.5.
hmm
Okay, but you are assuming like the same substance, am I right?
right? Like same solvent.
Same solute, same solvent, everything.
hmm
Okay, vapor pressure is going to be lower. That's right, because higher concentration, lower vapor pressure.
Okay.
Freezing point lower, that's good, higher freezing point. Boiling point, higher boiling point, lower boiling point. Vapor pressure lowering, lower is going to be larger vapor pressure lowering, smaller, okay, that's good. Larger boiling point elevation, that's correct. Larger freezing point depression, smaller. High osmotic pressure, low osmotic, that's good.
Okay. All right. Very good. Very good.
Mm.
All right.
But
Thank you.
but be careful. This is only for the same type of substance, solvent, everything. Or otherwise, even it can work for if the solvent is same, but solute is non-electrolyte in both cases. Or if
Okay.
the in that case, okay.
Oh, you're right.
Or
Right.
maybe the otherwise, if it is electrolyte, their want of factors are same in that case.
Okay. Okay.
Okay.
Thank you
Okay now.
for
Okay now.
clearing that.
Now let's do the following formula to the
Want me to
osmotic pressure.
want me to move this out of the way? I can get that out
No,
of
no,
the
no,
way.
it's no problem. You can move it if you want, because maybe we can show you some formula and other things. You can put on the side. Oh no, okay, that's okay. We don't need that one, but don't
Yep.
worry about it. Okay, I will show you here. For this thing, don't use this part. Why? Because this is only works if the N2 is very small than N1. Like the solution is very dilute. Okay. Then we can ignore the N2 from the denominator. So if the solution is not very dilute, then don't use this formula, okay?
Okay. Yeah.
Because it's only for very dilute solution.
Okay.
Like
Okay.
in that case, we can ignore. Now let's go to the osmotic pressure thing. Osmotic pressure pi is not the pi number, okay? Sometimes they write P, sometimes they write pi. But we are using the pi as a symbol, not as a 3.14 value, okay? I don't know whether what your book is using. Some books use the same P and some use pi.
Yeah, they're
But the thing
using
is
pi. They're using
pi,
that
but
like you have.
okay, but be careful. This pi is just as a symbol,
Yep.
not as a
3.1.
3.14. So
Yeah.
it's just a symbol, not that one. And the value of R is the same as the gas constant. Because why? Because for dilute solution, the solute behaves just like a gas particles. So same value of R. Now the other important thing is like, because pi is equal to, bringing the V here at the denominator, it will become, and 2 is the subscript I use for solute. So
Solute.
moles of solute.
Okay.
And this is volume of solution. And moles of solute per liter of solution is called molarity. So we are replacing this by M, which is molarity. It is not the molar mass. It is, I am using as a molarity. Now, further I am doing N2 is W2 over M2, because the number of moles of solute is the mass of solute in grams divided by M. So that's why I use M2 here, not M. M is molarity, but M2 is the molar mass of solute. So replacing the N2, I can write W2 over M2 RT over V, and this is equal to pi, mole, which is osmotic pressure. So this is the formula. Okay, and also the important thing is, in case for elevation of boiling point, normally they give the percentage in mass by mass, or weight by weight percent. So 5%, if they don't mention, we have assumed it that W2 is 5 gram solute and W1 solvent is 100 minus 5, 95 gram. So it gives both of us both things, weight of solute, weight of solvent. But in case of osmotic pressure, because we need the volume, So percentage normally, if they don't tell anything, we take as a mass by volume. Otherwise, if they give us, then we have to use that one. 5 grams solute, W2. Volume of solution is going to be 100 ml, which is equal to zero point 0.1 liter. It's clear? That's I have mentioned here. Any question about this?
No, that was the that 5% mass
But
volume
in case
solution.
if they give you, because normally we need weight by weight percent, mass by mass percent for elevation of boiling point, Raoult's law, and depression of freezing point. We need mass by volume for osmotic pressure. But in case if they don't give this one, give other percentage or other percentage here, then they need to give the density so that we can fix it. Okay.
Okay.
And now one more thing before we go to this problem. One term you have to know about osmotic pressure is what is the meaning of isotonic solution. Isotonic solution.
Oh, it's like neutral, isn't it? Like
No, it's not neutral. Isotonic solution means solutions with same osmotic pressure. Like suppose you are taking two solutions in the same osmotic pressure. Osmotic pressure. I'm not a biology person, but of course there is the blood grouping also match in different. A can be added to the A group. But also people say when they are transferring the liquid or something in body, they have to make sure that the solutions are isotonic.
Oh yeah, absolutely.
Internal pressure and outer pressure must be same. So same thing we use for osmotic pressure. Isotonic means osmotic pressure are same. I will give you one problem. Hold on just 1 minute. Suppose if I say, what is the formula for osmotic pressure? Pi V is equal to N2RT. And also we bringing that one, we can say pi is equal to MRT, molarity. And we also know that pi V is equal to pi V is equal to W2 RT over M2. M2 is the molecular mass of solute. And let me, I will make the problem first and then I will give you problem on this one. And let's first use a simple thing. So let's start first from here and then I will make that problem. Look the question number 26.
Okay. 26. A compound is found to have a molar mass of 598 grams per mole. All right. If 35.8 milligrams of the compound is dissolved in enough water to make 175 ml solution at 25 degrees Celsius, what is the osmotic pressure of the resulting solution?
Okay. So first let's write the data, what information we have.
Okay.
What is the molar mass of solute?
We have 598 grams.
598 grams per mole. How many milligrams mass? What is the weight of solute?
Yeah, 35.8 milligrams.
35.8 milligram. Dissolve in how many ml?
175 ml.
175 ml. Okay, I can let me have first. What other information is given there?
Temperature at 25 degrees Celsius.
25 degrees Celsius converting into Kelvin is going to give you 298 Kelvin. And what they're asking? Pi, osmotic pressure.
Yep.
R value you already know, 0.0821 liter atmosphere, Kelvin inverse, mole inverse. Okay. Now the one thing is we can do it, change the W2 in grams and volume in liter. Yep. Or otherwise we can just use the same number because this is milligram and this is milliliter, am I right?
You're right. You're right.
And the formula, what formula we have? Pi is equal to, pi V is equal to W2RT
Over M2V.
over M2, okay?
Oh, okay.
M2, okay, that's, you can take the V there, that's right, no problem. Now in this case, the thing is, if I will take the V also there, I can say W2RT over V M2, am I right?
Yes.
If, because this is this one is milligram, you can use the milligram and milliliter, it's no problem. I can assume this is gram and I can assume this one as liter. So ratio is going to remain same without even changing anything. Why? Because if you want to change the milligram into liter, what you have to do? You have to divide this by 1000, am I right? Am I right?
Right. Yep.
And when you want to change the milliliter into liter, again you have to divide this by 1000.
Yep.
So dividing both sides by 1000, you can just keep the same thing. Why wasting time?
Right.
Assume it is gram and it is liter, okay?
Mm-hmm.
Because converting, you will get the same thing.
So
if it is milligram per, so remember, like milligram per liter per ml is the same as gram per liter.
Okay.
Okay, no change. You
The
can
same
just
like
keep
ratio,
the
right?
same thing.
Yep.
Without wasting time.
Okay.
So now look here in this case. The problem is asking what? Osmotic pressure. Formula is everything is here. Just plug in the value.
Okay. All right, we go.
What you are going to use?
598.
What is it?
Or wait, I'm sorry. W2 is going to be 35.8.
Yes, I'm not changing into gram just because 1000 will cancel anyway. So what about R? 0.00821
0.821.
and 298
Yep,
Kelvin.
298 Kelvin.
What is the molar mass?
Molar mass is 598 grams.
598 grams per mole. And also remember,
The volume, yeah.
gram volume is how much is given there? We already volume is how much?
175 milliliters.
So 175. You can keep the same because we are keeping the milligram and milliliters okay, just like gram and liter. Because after changing, you will get the same ratio. What is the answer now?
I'm getting 0.008369. Oh, let me see. But hold on a minute. What did I not do or correct? 35.8 times 0.0821 times 298 divided by 175 divided by 598. Okay. And that must be coming out into atmospheres. Okay, so 1 atmosphere is 760. Okay, so 6.36 torr. Okay, C. Right?
What is the answer?
C. We had to, we got the answer in atmospheres, and then we had to convert it to torr times 760.
You're right.
I just saw.
Okay, you're very good.
Okay.
Now let's try the 27. Let's write the data. We will go to the blank page. Okay.
Okay.
What is the data for this question?
All right, we have 150 ml, so that's volume. V equals 150 ml. Sample of an aqueous solution, so we're dealing with water, at 25 degrees Celsius. That's T is equal to 298 Kelvin. Okay, it contains 15.2 grams of
W2.
solute, so that's W2. Unknown electrolyte. Okay, if the solution has osmotic pressure, so pi is equal to 8.44 torr. Okay, we can convert that later on to atmospheres. What is the molar mass of the unknown compound? Molar mass.
Okay, so we have all the information.
Okay.
And let's go to the blank page. Okay.
Yep.
Here. So I'm writing this formula pi. What they're asking?
They're at,
Pi V pi V is equal to W2 RT over M2. Am I right?
yes.
But I want M2, so I'm taking the M2 there and putting W2 RT over uh,
Pi V,
pi
yeah.
V. Pi V.
Okay.
Okay, because milligram per liter you can replace for put the same thing for grams per liter. Okay. So
Okay.
how much is the W2? I'm without that changing.
Yep. So we can keep it at 15.2 grams,
2
and then
and 0.0821
yep.
times 298 and
Pi, I
what is the
converted it.
pi is?
I
You have
can.
to okay, for converting pi, you can also instead of converting and putting there,
Yep.
you can do it like this 8.44 and I'm going to change this one divided by 760 right here.
Okay.
But when you will write this, the 760 will go up. So I'm writing here in this way,
Oh, we're gonna multiply it
multiplied by
by
7 because
760. Okay.
direct is there. Okay.
Good thinking. Yeah, I like that.
And then volume is, I'm using the milliliter because I'm using the milligram
150.
150. And
Okay.
this will give you the answer directly.
Nice. I like all those direct.
Yeah, it's just so save time
You know.
and also give more closer answer sometimes.
Yeah. I wonder what my teacher thinks. 223.25. Okay, and that's grams per the molar mass, right? The molar mass is grams
How much?
per mole.
How much you got answer?
223.25.
Okay, that's right. And how many significant figure we have to use here?
Let's see, 3. Yeah, 3.
I think
or
3, so I
2.
can say just
2 or 3.
223
So.
or more. Okay,
Mhm.
that's it. The answer is it clear.
Yep. Very good. Very
So
good.
let's see whether we have this answer or not here.
27.
223, closer
Yep.
that one. Yes, we have already here. Okay.
Echo. Yep.
So because in exam the time is also important. So try as to save time as much as possible. Okay.
Mhm. Mhm.
Why we waste time in changing into liter and milligram? I will get the same result.
Yep. You're right.
Now,
Yeah, I feel like I'm gonna do pretty well on this exam.
now I'm asking one question.
Yeah.
I am giving you this thing. 0.60 millimole per milliliter. I want you to convert this into mole per liter. What you will get?
You're a trickster.
Yes.
If I hadn't spent the last couple minutes with you, I would be guessing what the heck do I do. But since it's like
Because milli
the
is
same
here,
thing,
milli is here.
it's
So it's
this
the same thing.
because it's
Okay.
like I always used to get like tripped up over millimoles.
Yeah.
What is that exactly? Is that just a thousandth
Okay,
of
millimoles
a
is
mole?
just like, for example, when you convert into mole,
Mm-hmm.
what you do? You take the grams divide by the molar mass. Am I right?
Right.
You will get the mole. For millimole, you will take the milligram divided by molar mass. It's like 1/1000 of a mole.
Okay.
Okay, look, for
1/1000th of a
example,
mole.
let's have
Okay.
a take, show you.
Yeah.
Carbon. If you take 12 gram carbon, because grams, let's take 24 gram carbon, and the atomic mass is 12 grams per mole. Okay, what you will get?
2.
You will get 2, and what unit you will get? Gram will cancel, mole will go up, you will get 2 mole. Am I right?
Right.
Instead of this, if I am taking 24 milligram dividing by 12 gram per mole, 12 gram per mole. So if I take 12 gram per mole, I will get what I will get, because milligram means how you are going to convert this milligram into gram by putting 10 to the power minus 3. Am I right?
24 times 10 to the minus 3.
Yeah, converting milligram into gram.
Oh, okay, okay.
Okay, and you will get 2 times 10 to the power minus 3 mole. Am I right?
Right, right.
Because gram and mole, gram cancel,
Yep.
and you will get mole. 2 10 to the power minus 3 means milli. So instead of writing this, I can write 2 millimole.
Got it.
Okay,
Okay.
like this.
Got it. Yeah, I've
So
seen it
1
used
mole has
sometimes,
thousand
but
millimoles.
not
Yeah,
too much.
remember. Okay, what
All
next?
right.
Let's
Um,
try something isotonic solution, because I was saying isotonic solution. Hold on just 1 minute.
mhm.
Okay, I'm giving you this one. I'm not assuming the exact number, just assuming something, okay?
Got it.
Okay. Suppose solution of A, you can say 10%, it's like a hypothetical solution. 10% mass by volume solution of, and both of them are aqueous solution. Aqueous solution of urea is isotonic with 10.0. Let's make 3 significant figure. Hold on just 1 minute. Is isotonic with 30%, and again this is mass by volume. Aqueous solution of another compound X. What is the molar mass of X? Find the molar mass of X. How you are going to do this thing?
All right.
It is 30.0, keeping 3 significant figure. Let's.
Okay. Let's see. Thinking. If it's isotonic, then that means that the osmotic pressure is the same. So if I figure out the osmotic pressure,
I will make the
or
data. Okay.
okay,
You can write the data like this: urea solution. Okay. And I'm writing the unknown X. Okay.
mm-hmm.
Separate thing. It is 10%. Am I right?
10%, right?
10% mass by volume.
Yeah,
What it means?
10 grams of urea in 100
So
ml of water.
W2 is 10 grams.
Mm-hmm.
And how much is the volume?
100 ml.
100 ml means how many liter? Yes. Ml means 0.1 liter. Am I right?
Yes.
Okay. And what is the molar mass of this? I already gave you 60.
60.
Okay. That's information I gave you. Here I gave you 30%. So the 30.0% means W2, and now because in order to distinguish them, I am putting W2 dash. Okay.
Okay.
W2 prime.
Got
30%, 30.0 gram. V prime I am writing again 0.1 liter. M2 dash you have to figure out how you are going to solve this problem. And what I am saying, solution is what?
Isotonic.
Solution is isotonic. What it means?
Like you said, the
Osmotic pressure
is
is
the same for each.
If this is pi, this is pi dash. Okay.
Mm-hmm. So that means I should be able to.
So they are same. It means pi is equal to pi dash. That's the meaning of isotonic. Both osmotic pressure is same. Now solve the problem.
Okay. Let's see. I'm going to use the pen and write here. Okay, so if that is equal to that,
they are not going to give you this equal, because this I'm writing because I'm saying what? Solution is isotonic. So it means both have the same osmotic pressure.
I'm just going to write out, I'm writing this generally out right here. Whoops.
Mm-hmm.
So W2 RT over M2 V
Very good.
should equal W2 prime RT over M2 prime V prime. Now let me just think for a moment. The R and the T, I'm just trying to think if I can get rid of those somehow, or they'll still play into the mix. So I'm trying to solve for M2. Okay, so what I'm going to do is I'll flip them. If I flipped them, okay, if I did that, it'd be M2 prime is equal to, I'll flip this one, M2
Why not you first make it simple?
V hold on, M2, if I flip them, so that's there, okay, times W2 prime, whoops, mind if I scroll down just a little bit?
Yeah, sure.
Okay. Yeah, so I'm just gonna.
And isotonic, when I'm saying isotonic, it also means like at the same temperature.
Okay.
Temperature is
so if the
same.
Temperature is constant.
So you can say temperature is same for both of them.
Could I get rid of these?
Yes, very good.
RNT. I
And
can
also when I'm saying percentage, what is the volume also here and here,
100 ml.
which is point 0.1,
Boom,
0.1
boom.
liter. So also same, am I right?
Wow. Yep.
So
Yep.
now you have a very short equation now.
Yep. W2 over M2.
Hmm.
Yeah. All right. So now I'm gonna solve for it. We said W2 prime was 30 grams times M2, which was 60 grams, divided by W2, which is 10 grams. So it comes out to 180.
Very good. That's right. Because I assume the glucose unknown.
Wow.
It's clear?
Yes, thank you for showing me that.
Normally they are going to tell you, but if they don't tell, isotonic means like they are at same temperature normally.
Mm-hmm.
So we are cancelling the RT, and because the percentage means both have 0.1 liter, zero point 0.1 liter, cancelling that. So you get a very simple equation now, this one.
Yep.
Okay?
Yeah, I was
And now
just
you
thinking
can
about it.
rearrange
It's
and
like,
get the answer. Is it clear?
yeah. Yep. Yes.
So remember one thing, not only for this, but any other question. Whenever they are showing same elevation of boiling point, same depression of freezing point, or maybe same vapor pressure,
Mm-hmm.
always write the formula for just you did correctly here, because you arrange it for osmotic pressure, because you know the osmotic pressure is same.
Right, right.
If suppose they say elevation of boiling point is same for two solutions, so do the same thing. What is the delta TB? For example, delta TB, I gave you this formula also, am I right? W2, what is that one? W2,
Oh, times,
sorry, KB, W2 times 1000,
yep,
am I right?
over
And
W1. I'm sorry, no.
W1, W1, that's your right.
Time,
And molar mass of solute, all
molar
right?
mass of salt. Yes, yes.
If this same that elevation of boiling point is same, so it means this is same. So I can connect another one. You can put, if the solvent is same, don't put prime. Now if suppose W2 dash prime times 1000, suppose, okay, W1 prime and M2 prime. If solvent is same, you can now KB can also be cancelled.
Okay.
If solvent is same, am I right?
Mm-hmm, mm-hmm.
1000 constant also cancel.
Yep.
So now you can plug in and you can calculate easily. If you know that that many percentage and other percentage, they show the same elevation of boiling point.
Mm.
It's clear? So you have to make it like this, make it equal, cancel the common thing, and then you can easily solve these problems.
Got it.
Okay?
Yes, thank you.
Now, but in case of this one, you can't cancel, because if it is 5% weight by weight, it means W2 is 5 gram. What is the W1?
What is it? 95? 100 minus 5?
95 gram. If suppose W2 prime is 10%, so 10 gram. So what is the W2, W1 prime?
90 grams.
90 gram. In this case, you can cancel W1 prime. You have to put that one. Is it clear?
Okay. Yes, yes. Yep.
Okay.
Yep.
Now try this one. 25.
25. All right, place the following solutions in order of increasing osmotic pressure.
Getting lower to higher. You have to go the lowest one first, then highest will be at the end. Less than, then the.
Okay.
First of all, check whether both all of them are electrolyte,
Mm-hmm.
non-electrolyte.
Yep. Yeah, it looks like we have this is a non-electrolyte.
So I is equal to 1. Am I right?
Mm-hmm. All right, so I is 1.
Mm.
Here we have I is equal to 3.
Mm.
Here we have I is equal to 2.
Okay.
Now, yeah, we're dealing with molarity. We have pi is equal to MRT. Um, but in this case, since it's electrolytes, let's see. So it'd be
You can also put, but you don't need to do the calculation here.
oh, since
But of
it's
course,
directly
pi v is equal
proportional.
to uh, what I told you, n pi v is equal to n to RT. Am I right?
Mm-hmm.
You can put the I here if you want this I. But we don't need the calculation
Yep.
because the concentration is same. Am I right? Concentration is same. So now it only depends on I.
Yep. Okay. So increasing, so it would be it'd be 1, 3, 2. 1, 3, 2.
1, 3, 2. You are right. Because you have to multiply, but only when the concentration are different. If the concentration is same, don't worry about it. Just look the I.
Okay. Oh yeah, you're right. You're right.
You can
Just
save the
just
time.
do it by the I factor. Okay.
Mhm. Now look this one.
Choose the aqueous solution with the lowest vapor pressure. Okay, this will be a good quiz. Let's see. These are all solutions of non-volatile solutes, and you should assume ideal Van Hoff factors where applicable. Okay. Choose the aqueous solution with the lowest vapor pressure. Okay. Okay. Okay.
Concentration is same or different?
Concentrations are different.
Okay, when
Yep.
the concentration different, then you have to consider both things, I and concentration both.
Okay. This one here is I is 1. So it's going to
Which one?
be
No, why this I is 1?
oh no,
I
it's
don't
2.
think
No,
it's
it can
2 because
ionize,
this
yeah.
is acetate and this is Li, 2.
Oh, I didn't even okay.
Li is metal, this is the whole thing is another. Let me have a write this, show you. Li, because we know that Li has a +1 charge,
Mm-hmm.
plus, and this is C2H3O2. It's going to decompose into Li positive plus C2H3O2 negative, two particles. What about the I for the second one?
3.
Yes.
Okay, and then C is going to be 3. So that's 0.18.
You're right.
Okay, and then C2H6O2. Is that sugar? Some kind of
No,
glucose?
this is actually ethylene glycol actually.
Ethylene. Oh, EG.
Ethyl.
EG. Okay.
But you can, this is like a non-volatile. So just keep 1.12.
Oh, and like you said, the one that is most volatile has the highest vapor pressure. Is that true?
Okay, yes, right. But all of them are solvent are non-volatile. Solutes are non-volatile. So don't worry
Okay.
about it. They
Okay.
are saying solutions of non-volatile solute. So don't worry about it, okay? The only thing you have to look now here is which, and because they're all saying aqueous solution, solvent is water.
Mm-hmm.
So solvent is water in all cases. Now, which one has the higher concentration? Effective, like after multiplying by I.
C.
Which one is the highest? C. This one is the highest. So highest means
Oh yeah. So that it's gonna
lowest or highest vapor pressure.
it's gonna decrease, go low, right?
Lowest. So this one is going to be lowest. Which
Okay.
one? This is the 0.18? Yes, 0.18. So this
Yes.
is going to be lowest vapor pressure. It's clear?
Mm-hmm.
Suppose if the highest vapor pressure, then what? Who is going to win if it is highest here?
Let me see. Yeah, it'd be A, wouldn't it?
Mhm. In that case, I think there is two competition.
Hold on. Let me see.
No.
Zero point
Which
zero
is, what
six.
about this is 0.12?
Yes, B. That's
This
B.
one and this one is going to be same almost. 0.12, 0.12.
But what about you said the highest? Which
Because
solution?
highest means, this one is lowest. Oh, no, then this is lowest, am I
Right.
right?
Yeah.
Lowest, okay, then the A is going to be the answer in
The
that
highest
case.
vapor pressure is this one, right?
Yes, you're
Okay.
right. Because I didn't see 0.06. Is it clear?
Yes, I have to. Yep. Yep.
What about 23?
23. Choose the aqueous solution that has the highest boiling point. Alright, these are all solutions of non-volatile. Okay. Alright. For A, let's see, I'm just gonna try and move this down. Let me. Alright. C3H8O3. Is that a non-electrolyte? I'm not sure what that
Normally,
is.
when it is carbon compound, something like, just assume it is non-electrolyte.
Okay. So that's going to be
Assume it's non-electrolyte, yeah.
0.200, or I is
1, you can
I
consider.
is 1. Okay. B, we have Li2SO4, so that's I is equal to 3, so 0.3, 0.3 M, right? C, we have Na3, so that's I is equal to 4, so 6 times 4 is 24, 0.24 M. D, we have NaNO3, so it's I is equal to 2 and 0.2 M. Okay, now I have to just look at these and decide. Highest boiling point. Okay. So it'd be B.
B, you are right, because 0.3 is the highest, am I right?
B, yes.
That's correct. So it's clear how to answer these type of questions?
Yep. Yeah, it's definitely good. I definitely suspect that he's gonna ask us things like that to arrange them.
Yeah,
You know?
definitely he's going to give you. Okay, tell me about this.
All right. The boiling point elevation sets TF or delta TF. I'm sorry, delta B,
TF.
delta TB. I'm sorry.
Oh, TB, sorry.
Delta
Yeah, TB.
TB of an aqueous sucrose solution is found to be 0.39. Delta TB is equal to 0.39 degrees Celsius. What mass of sucrose, molar mass, would be needed to dissolve in 500 grams of H2O? Okay, KB
K
is
is
equal to
0.512.
Okay. Okay. Yeah, this is gonna be. We have delta. I'll write it. I was writing it down. I'm gonna write it down right here. We have delta TB is equal to KB times W2 times 1,000. Oops. Over W1. And it's asking me, hold on, what mass? Okay. So molar mass, W or M2. Alright, so now I'm going to solve for W2 is the solute. What mass of sucrose? W2. Okay, so I'm going to have to solve for that one. So I'm going to do...
Okay. What you're doing here?
We're solving for W2, right?
Okay, so why you are writing equal here? This is separate. You are rearranging, am I right?
Yeah, I'm rearranging those.
So just put separate line here because they are not going to be equal after a rearrangement. Just write W2 and then put all others. Yeah, right. Mhm. Very good.
Okay. So in my calculator, I'm just putting in delta TB. So that was 0.39 times W1, which is 500 grams, times the molar mass, 342.3, equals, divided by KB, which is 0.512, equals, divided by 1,000. And that equals 130 point, yeah, there we go, E.
That's correct. It's clear?
Yeah,
It's very easy.
that's a good type question.
Mhm.
For sure. Oh yeah. Yeah,
These are
I love those quick formulas that you have. It's so much. Man, you should. It's not nice, but like the students in the class, they like struggle because the teacher goes, he teaches everything step by step, and like,
actually this habit of making combining formula
yeah.
I used when I was studying my I was myself as a student.
Hmm.
I said, why I will do so many steps? So I just combine them all together.
Yeah, it's really good, you know.
Mm.
It's real good. It's I tried showing some of the students,
Like,
but they're
like
like,
one
"Oh, it's
thing,
too much." I'm like,
because maybe when if someone working in the lab, in the lab, normally when you work in the lab, chemistry lab or something lab,
hmm,
what happens? They have like a bottle of sulfuric acid, another liquid
yeah,
there, and the bottle says specific gravity of that liquid, percentage, maybe mass by volume, percentage, something like that, and you want to know the molarity.
hmm,
So there are many steps to do and get the calculation. So I just combine them
yep,
to do that things
yeah.
together.
That's the way to go.
Yeah. So let's try this one, another one.
Okay,
Mhm.
which one? 15,
This
16.
one, 16.
Okay, calculate the vapor pressure. Okay, of a solution made by dissolving.
First write the data so we
Okay,
can see whether your data is good or bad.
yep. All right. I'll yeah, I'm gonna write it here. All right, so we're trying to find the vapor pressure, and that's gonna be
What is the symbol for vapor pressure of solution we use normally? What I have used in my formula sheet.
P1.
No, I
No.
have used, if it is
Oh, I'll
only
check.
solute and
I'll check.
solvent, I used P only.
Oh, P. Okay.
But if there are more than one solvent, then I use P1, P2, something like that.
Okay.
But here is only one solvent, one solute, so P. And what I use for the vapor pressure of pure solvent? Symbol,
P naught.
P naught. That's right. So what is the P here?
Okay. All right. So P is what we're trying to find, but
That's very good.
the formula is um, X. It's the mole fraction times the molality, right?
No, no, in this case, the formula is P is equal to P naught into X1. There's
P.
many the other
Oh,
formula, like
okay.
P is equal to P naught X1.
Okay. Okay.
And what is X1?
Okay, so I'm gonna just I'm gonna have to calculate. We have 109 grams of glucose with molar mass of 180. So that's 109 divided by 180.2. Okay, so that's our moles. So we have moles of glucose and moles of H2O. Or we can just calculate moles of glucose and do 1 minus, right?
Yes, that's right.
So I could do, let's see. Um, yeah, because the moles of glucose is 0.60.
But always check because normally it's okay minus one from one.
Mm-hmm.
But you can also double check this is 920. Okay, what is this?
Yeah,
What
I could do water. If I just stuck with water, 920 ml is also 920 grams
the
of water.
grams roughly
Right.
like same thing.
So 920 grams divided by 18 grams per 1 mole. So it's 51.
You just verify that thing, okay?
Okay. What, like
That's
the...
going to be same, no problem. Because there's only two components, so no problem.
Alright, so 51.1... 51.1 moles of water. Okay, and let's see, sets moles of water, and now P naught. Yeah, the vapor pressure. So if we multiplied this by 23.76. I'm just trying to make sure. Let me see. 51.1 moles plus the amount of moles that we had, 0.60. I'm going to take 5. The total of moles is 51.705. Let's see. 51.11 over 51.705. So I'm getting a mole fraction of 0.9885. So then if I multiply it by 23.76, I'm getting I think this is the vapor pressure of the solution. 0.9885 times 23.76 is at 23.48 or 49. Is it A?
Okay, just let me do it.
No problem.
605. What is your X1?
For X1, like what I ended up doing was I added the moles. I took the moles of water divided
How much is a mole of water?
51.1.
Okay, that's right. And how much is a mole of glucose?
Glucose, I took 0.605 and I added it to that of the water. And that's what I use for the denominator.
Okay.
To try and get the fraction.
So what is the X1 comes?
This is what I got for it.
0.988. Okay, that's correct. Okay.
And then I multiplied it by 23.76.
By the pure, yes. What is the pure vapor pressure? 23.76. So yes, that's you're right. Okay. That's good.
So it was important because at first I was thinking I need to get the moles of glucose and then divide the moles of glucose by the total number of moles. Because if I did that, then I would have gotten 1 minus 0.9885, and I would have been
What you mean, like, because
like,
why, if you want, what you are, how you are doing this one minus, I don't understand.
no, well, I had to correct my thinking because I was thinking in order for me to get the mole fraction, I would have to use the moles of glucose as the numerator, but that's wrong. It should be the moles of water, because the water is what's given us the we're dealing with pure water here. So I had to correct my thinking.
So in order to get the moles, you will get the gram, this is the grams because density is 1. Divide by 18, you will get 51.11 mole. Am I right? Now because you need the mole fraction of solvent, water. So you will take the moles of water at the top and total moles of both of them at the bottom. Yep. And then you get this. That's good.
Yeah, I had to correct my thinking. At first I was wrong. So.
Okay, that's good.
This is a good practice problem.
Okay, let's see.
Yeah, we could do like one more, and I'll let you go for the evening. And
Okay, no problem.
I think what I'm gonna do is
I want you to do this one.
I'm gonna review chapter 12 and make sure I'm good on the intermolecular forces and all that stuff. Maybe
do the question number 12.
Number 12. Determine the freezing point, delta C. So the freezing point is TF. Okay. Mole. All right. Sorry.
No problem.
All right. Determine the freezing point of a molal aqueous solution of this. Assume I is 2.0. Okay. So we have. Okay, can I use, I'm going to use this space over here, okay?
Okay, you can use.
Let's see.
What is your answer?
Yes. Yeah, I'm gonna just do it on my piece of paper and try and solve it quick instead of using the mouse.
You're writing the correct formula. That's not a big deal. You're writing everything correct. Just solve it.
Yeah, I is 2, KF is 1.86, and then the molal that we had was
As by mistake class cancel.
No, it's okay.
Okay, no problem. You will do this. Let me show you. You will do the same thing you are doing correctly. I into M into KF, sorry. Whatever you will get, that is the delta TF. That is what?
Delta TF.
And the answer was like minus, the answer was 0.56 something, whatever it is.
Mm-hmm.
But that is not the freezing point of the solvent,
Right.
pure
Right.
solvent. So because it is an aqueous solution, so whatever you are getting the delta TF for aqueous solution, the freezing point is going to be the same number with negative sign. Because freezing point of water is 0. You are going that much below 0. So your answer is going to minus that answer.
Okay. Okay.
Is it clear? Suppose your answer got you got answer point 0.5,
Mm-hmm.
0.5.
It'd be
So what
zero
is the freezing? Is going to be minus 0.5
minus zero.
answer.
Okay. That'd be the
Because
that'd be like
yeah,
the new freezing point after
on
the.
of the yeah, because the solvent is water.
Okay. Okay.
Okay. So 0 minus that number will be the answer.
Got it.
Clear?
Mm-hmm.
So okay, today